Good morning, John. I've got shingles, and what do I do when I'm sick? Well, of course, I research my disease until I discover how bizarre and fascinating it is, and then I let that distract me from my disease, of course. And this is not the first time I've done this with shingles, but it turns out shingles is very bizarre, and in a way that is even weirder than I thought, and also tells us something about the evolution of early hominins, which is not what I was expecting. But to get there, the weird thing about shingles is that the virus that causes it also causes another disease, which is called chickenpox. This is part of why diseases are not just named for their virus all the time, like SARS-CoV-2 is a virus, COVID is the disease it causes, varicella-zoster virus, or VZV, is a virus, chickenpox and shingles are both caused by varicella-zoster virus. But VZV has a crazy life cycle, and I'm going to give you a very basic version of it. Step 1, you breathe in a viral particle. It infects the cells of your lungs, and then it moves into the immune system, which carries it throughout the body, including to the skin. When the white blood cell touches skin cells, the virus basically leaps directly from the white blood cell into the skin cell. And that is where the viral particles begin to grow in earnest, and they cause a bunch of skin cells to fuse together into giant virus particle creation machines. So instead of just filling up the cell with viral particles and then exploding the cell, which is what happens with most viruses, it merges together a bunch of cells into a big multinucleated virus machine. Gross. I don't love this. But eventually a bunch of those are created and they pop, and that creates the blisters. And this is also how the virus infects new people. This is gross. It is unusual, but it's not droplets of spit in the air that make chickenpox airborne. It is instead mostly pus in the air that you breathe in that causes new infections. I'm sorry. But that's just step 1. And I know that was a long step 1. Step 1 had a lot of steps. Step 2, as the immune system is taking care of the infection, the virus moves from the skin and starts to infect nearby nerves, but only in a very chill way. And then it migrates down the nerves without giving the immune system a bunch of signals. So it's in these long-lived cells. It's mostly not getting into the blood and lymph where there would be signals to come attack. Eventually, these viral particles get to the ganglia, and there they enter into dormancy. So 2 to 5% of ganglia cells are infected with single-digit numbers of viral particles that go dormant. And they just hang out there. And then later in life, these viruses can reactivate, especially if the immune system is having a hard time for some reason. The infection then goes out into the nerves, which is super painful. Now, the virus doesn't care about this, but the goal is that the virus moves back through the nerves and eventually to the skin, where they again create blisters that shed viral particles. But again, the whole time this is the same virus. So if you get infected by these viral particles from the shingles blisters, and you do not yet have any immunity against chickenpox, you don't get shingles, you get chickenpox. So why am I saying this is so weird? It's weird because life doesn't do super complicated stuff like figure out how to infect and lie dormant in the nervous system for 30 years and then reemerge in the correct moment when the disease is already super good at surviving just by being extremely infectious. In the world that we exist in now, this step where it reemerges as shingles doesn't do anything for the varicella-zoster virus. Measles doesn't need this. It just infects and then it moves on to a different group of people. There's always new kids being born. Those kids haven't been exposed to measles yet. They will eventually be exposed to measles and they will get measles, unless they get the vaccine, of course. So why is VZV doing this very weird, very complicated thing while the measles virus is not doing anything like it and does not need this? Guess what? There's a reason, and I can tell you very quickly, measles is younger than writing, the technology of writing stuff down, while shingles is older than humans. So people who get infected with measles once or VZV once, they never get it again. You can never get chickenpox again after you get it one time. And also, both of these diseases are very contagious. And this is not a problem now, because there are lots of humans and we all live very close to each other. There's always a population of uninfected kids for chickenpox or measles to move into. Unless it's a pretty remote island. And measles actually cannot survive in a group of people that's less than 400,000 people together. But mostly, that is not how humans live now. But VZV, or VZV-like viruses, are very old. There's a simian version of VZV that has both a chickenpox-like phase and a shingles-like phase. So the common ancestor of that disease and the disease that we get is very old and had this trait. The ancestors of this virus have been using this strategy since way before humans ever existed. And it had to evolve this complex lifestyle because otherwise it would have gone extinct. When groups of hominins were small, and did not have a ton of contact between groups, a measles-like infection would burn through the population and create group-wide immunity to the virus. So really, like, a measles-like infection could not have existed until after agriculture, which is why measles did not exist until after agriculture. By the time a new bunch of kids were born who did not have exposure to the virus had burned itself out. It was gone. And so, the ancestor of VZV evolved this trait, allowing the virus to lie dormant for many years and decades, and then it would reemerge when a bunch of young members of the group had been born who had never been exposed to the disease. When that happened, sometimes the shingles blisters would cause a new infection in a young person, and from there, it would cause the entire community of young people to get chickenpox. It would spread rapidly through the whole community, and then later, when those individuals were older, there would be some shingles cases which would reinfect that next cohort. On, over and over again, a two-phase life cycle for a virus for millions of years. VZV no longer needs to do this. Just like measles, it can spread from population to population with no problem, just as chickenpox. But a million years ago, it needed this trait. It needed to be able to hide for decades, waiting for unexposed individuals to be created so that it could continue existing and not just burn through a population and never be able to infect anyone ever again. And it needed to do this in ways that were very specific, not just to the biology and bodies of its hosts, but to their social structures. That's cool. It sucks, but it's cool. Now, interestingly, VZV is technically eradicable. Just like measles, just like smallpox, it is a human-only virus. It does not infect any other animals, including chickens. We are not actually sure why it's called chickenpox. It has nothing to do with chickens. But eradicating VZV would be very hard, in part because unlike measles and smallpox, it lies dormant in people's bodies for decades, and unless you keep the whole population vaccinated for the entire life cycle of the disease, it's gonna break back out in unvaccinated populations because of shingles. And so, by luck, this dumb little virus evolved a super complex trait for a world that existed when people weren't even people yet. But now that trait is helping it evade our extremely modern technology. Very weird, very cool. John, I'll see you on Tuesday.